So this last example on your paper, here's a function f of x is 5x minus x squared. We've been asked to find any relative extreme values and where this function f is increasing and where it's decreasing. We'll recall from section 4-1 that a function only has a relative extreme value any place that there's a critical point. So that's a place where f prime of x equals 0 or is undefined. So I'm going to start by finding f prime of x. It's going to be a pretty normal progression for you guys for most of the rest of the semester. I want to know where that derivative equals 0. And I can solve and I get x equals 5 halves. I have to also check for any place that the derivative f prime of x is undefined. But notice f prime of x is just a linear function that's defined for all domain values. So my only possibility for a relative extreme value is where x is 5 halves. I can figure out when I plug in 5 halves for x, what's the y value that comes out? I'll fast forward here. The answer is 25/4. The only thing left to decide is, compared to its neighbors, is 25/4 a high up point or a down low point? Is it the top of a peak or is it the bottom of a valley? So what I'm going to do, I'm just going to pick any two other values on this function. I'm going to pick 0 and 5. This works. I can pick any other 2 points because 5 halves was my only critical point. I have to make sure not to cross over critical points. When I find out the y value when x is 0, I get 0. And to find out the y value when x is 5, I also happen to get 0. So I can say that f of x has a relative maximum because 25/4 is higher up than 0 and 0 at, I'm supposed to find the maximum value. So that's going to be, I could give the answers in ordered pair, 5 halves, comma 25/4, or I could say of 25/4 at x equals 5 halves. They're both correct. Now I've been asked to find out where f of x is increasing. Well, recall that f of x is increasing anywhere that f prime of x is greater than 0. So I'm going to find f prime of x, which is 5 minus 2x, and set that greater than or equal to 0. I get 5 is greater than 2x. Now notice I don't have to go through the process of making the number line and testing points because this inequality happens to be linear. I could, but I don't have to. This is the faster version. I'm just going to solve, and I'm going to get 5 halves is greater than x, which means x is less than 5 halves. So f of x is increasing for all x is less than 5 halves, or I can give my answer in interval notation. That would be negative infinity up to 5 halves. Now I could say that my question part C was, where is this function decreasing? Well, this is nice because I've actually already done all the hard work. I know that f prime of x is positive when x is less than 5 halves. So f prime of x is negative when x is greater than 5 halves. So I could say that f of x is decreasing for all x's greater than 5 halves. Or I could say that f of x is decreasing for all x's from 5 halves up to infinity. There's your answer.